Well, hi, good morning. Welcome to my shop for another day on this radio. I think today will be pretty interesting. We're going to try to increase the AVC voltage, assuming that for some reason it's low. Well, it's no more than an assumption. It's mostly because the eye here won't close. So there's something going on that's causing that. But before I get going on the video, I kind of want to make a personal apology here. For a word I use occasionally, I do it thoughtlessly, and when I catch myself, I either apologize on the spot or I actually go back and edit the video to remove this word. And I think 2 videos ago, maybe 3, I'm not sure now, I just woke up this morning and realized I failed to edit out this word. This is a word that my mother used all the time when she was upset. I must have heard it 5 times a day, easily, coming out of my mother's mouth, and unfortunately it comes out of my mouth too. Now, I'll tell you what the word is. The word is cotton picking. Now, maybe this doesn't mean anything to you. Great. But, and certainly when I was a kid, it meant nothing to me. I used it regularly. My mom, it was just a word you used when you were upset. But now I realize where the term has come from. I realize what it's really referring to. And I'm doing my best to drain that out of my vocabulary, but I'm failing. I'll probably never get it completely out of my vocabulary. So even if you don't understand what it is I'm talking about, I feel better having offered an apology to anybody I might have upset by using that term. And going forward, I apologize now in case it comes out of my mouth again. Okay, so low AVC voltage. Why do I think that? Well, earlier when I was doing the alignment and that, I discovered that this meter would comfortably come up to about 6 or 7 volts. Pushing it higher required a very large input signal to the radio. In fact, a stupidly large one. You might get up around 13 volts or so. I noticed in the tube manual, the magic eye is looking for as much as 18 volts. And now we're going to look and see what a couple of these other tubes that are controlled by the AVC are looking for, and see if they aren't all looking for 18 volts. You'd have to guess if that's the case. The radio is designed to produce the 18 volts on a strong signal. And if it's not doing it, something must be wrong. So one of the tubes that's controlled here is a 6SK7. Let's take a look at what it says there about it. 6SK7. There should be I believe this would be a remote cutoff tube. Don't see that written there. Maximum ratings, grid number 1, maximum, grid number 1, positive bias value, 0 volts. What the heck is that? That's not what I'm looking for. I'm looking for, how about here? Characteristics, grid number 1, only a minus a volt. Where's the 18? Control grid bias. Variation will be found effective in changing the volume of the receiver. Variation of the grid bias. In order to obtain adequate volume control, an available grid bias voltage of approximately 50 volts. Whoa! 50 volts will be required. The exact value will depend upon the circuit design operating conditions. This voltage may be obtained depending upon the receiver requirements from a potentiometer across a fixed supply voltage, from a variable cathode bias resistor, from the AVC system, that's where this one's getting it from, or from a combination. 50 volts. Well, okay, that's not quite what I was expecting. Now, there's one more tube, 6, I believe, maybe the 6SA7 is also controlled by this AVC voltage, 6SA7. Here we are. Let's see what this one says. This is under maximum watt. Typical operation. Grid number 1. Grid number 1 resistor. I don't know. Grid number 1 current. No. Grid number 3. It's grid number 3. Grid number 3. Control grid. Bias minus 2 volts. You know what? This is going to have another paragraph down here about Because of the special structural arrangement of the 6SA7 and 6SA7 GT, a change in signal grid voltage produces little change in cathode current. Consequently, an RF voltage on the signal grid produces little modulation of the electron current flowing in the cathode circuit. Consequently, an RF voltage on the signal grid produces little modulation of the electron current flowing in the cathode circuit. This feature is important because it's desirable that the impedance of the cathode circuit should produce a little degeneration or regeneration of the signal frequency input and intermediate frequency output. Another important feature is that because the signal grid voltage has little effect on the space charge near the cathode. Now there's something that seldom is mentioned. One of the most important factors in the operation of the tube is the generation of a space charge, or an area inside the tube in which there is a charge in space, just kind of between the cathode and the grid. Space charge near the cathode. Change in AVC bias produces little change in oscillator transconductance and in the input capacitance of the number one grid. There is, therefore, little detuning of the oscillator by AVC bias. So that's the whole deal. I'm going to try to use AVC, and you could cause the oscillator that's operating with that tube to vary in frequency, and then that would ruin the radio basically. Okay, so I'm not getting anywhere here. This is not helping me one bit at all. I don't know. What is the voltage supposed to be? So, okay, I guess I'm going to have to study the circuit very carefully and see if we can determine something there, but I don't think I can, frankly. I think this is really a case of find two weak tubes, change those two weak tubes, because I believe there's two weak tubes in here, put them in and see if it works, and don't worry about anything else. I think that's a better way to go here. I think that's a better way to go. Okay, so I'm going to test some of these tubes again, certainly these first three, and see if any are weak and could benefit from replacement, or I'm going to do a replacement and see if that has an impact. Something's going to happen here. Okay, I've got the first tube plugged in, 6SK7. Let's just double check. 6SK7, 6.3 volts, JR heater settings, 47653. 47653. 7653 was my phone number when I was a kid. 22 and 72. 72. Okay, tube should be warmed up by now. Let's check for shorts. No shorts in the tube. There we go. Oh yeah, what's it supposed to come up to? 6SK7, 1200, throw it away. 1900, be happy. 1200, so on the 3000 scale, 1200 around my finger. Beat my finger. That's doing well. That's 1600. I don't think we can declare this tube to be weak. This tube's great. Okay, now there's another one of these exact same tubes in here. This is actually this particular tube. This is the IF amplifier. This tube is critical in exactly the kind of problem we're having with this radio. Let me just be absolutely sure. 6SK7. So maybe this is the weak one. The mixer tube, the 6SA7, if it's weak, you know, it can be weak in a couple different ways. It can be weak on the oscillator side, weak on the amplifier mixer side. I don't really know what to say about that. Could that be causing low AVC? I suppose. A weak oscillator signal would weaken the output, or would weaken the AVC too. Okay, this guy should be warmed up. So flashing short light is fine. 1200 was here. Well, it's just like the other one. I'm watching the needle, it's slowly sinking a little bit. Replacing good doesn't mean anything. It's actual numbers. If we want to do replace good, we would do it like this. It's about the same spot, right at the bottom of the good. Bottom of the good. When the actual measurement, 1200 is down here. Well, okay. I just don't see that this could be an explanation. I thought there were 2 more weak tubes in here. There's only 1 more tube to test. And another thing we could do is I could find some stronger versions of those tubes, the 6SK7, stick them in and see if that does anything. This is the 6SA7 mixer tube. Let's set up for that. I'm just going to let the video roll here. 6SA7. 2 tests on this. JR 73465. 73465. 21 and 34. 21 and 34 to make the English read properly. We're on the 3000 scale setting now. SA7. Okay, so this is the amplifier section of this tube, and we should be above 470. That's way down here. We just have to get above my finger there. Looking for shorts. It's not flashing very well. Oh, for crying out, no wonder. It's sitting here. Tube is failing. Tube is failing. Okay, while it's warming up, we'll double check. My roll chart tends to roll a little bit, and I end up reading the numbers for a different tube. 73465. 73465. Yeah, I think everything's good. 2134. 2134. Okay, let's try the short thing again. Oh, I left it on shorts. Here we go. Okay, no shorts. If there was a short in any of these tubes, I don't think the radio would operate at all, and something bad might happen. In this case, we're now looking at 470 down here. Well, that's right on 470. So it's like at the bottom of the heap. That's actually 2 tubes that are at the bottom of the range. Now there's another section to test here. 5346 with a 7. 5346 with a 7. 2134. Those remain the same. P4. Same number. 470. It's higher. If I replace all 3 of these tubes, they're really. Well, let's start with this one. Let me replace this one. This is very low on the oscillator. It seemed to me the oscillator was plenty strong in the radio as far as I could determine, but I never really measured it. Measuring the strength of the oscillator is tricky. You can do it with grid voltage on the mixer tube, but I think mostly the idea is to try to read the current flow. Oy. Oy, oy, oy. Okay, 6SA7. 6SA7. Somewhere I've got a box. Let me hunt them down. I'll get one tested and ready to go. So what I'm going to do here is get the radio operating with its original tubes, except for the 2 I very early on replaced. But in terms of these 3 I've been fooling with, the original ones are in. I'm going to operate my signal generator, going to put a controlled signal onto the radio, going to tune it in, going to read the voltage over here, and then do the tube swapping thing and just see what happens to this AVC voltage. Now, one of the things that could be happening with this radio as I'm switching tubes is it could be affecting the alignment. So I have the alignment set now so that the signal shoots through the radio very nicely. If I change these tubes, it may not shoot through the radio so nicely because of alignment issues. Now, that's not supposed to happen. Good designers design these radios so you can change tubes and it doesn't throw the radio way out of whack. In fact, it should have really no effect on the tuning of the radio. But how do I know that's really the case? And how do I know that this low, apparently low AVC voltage being produced by the radio is real? I still don't even know if that's really real. It's just based on the eye not closing. You'd have to think when this radio came out of the factory, you tune in a signal and that eye is just going wild because that sells the radio. Okay, so I'm going to turn this guy on, let him warm up. My signal, my frequency counter there is doing the 8 thing right now, and we'll come back when it's warmed up and establish a baseline measurement. Okay, just make an observation here. So I know it's hard to see the eye in the camera. I can't do any better than that. It's very clear with my own eyes looking at this. The pie is practically completely dark. Not in the camera though. So I'm on the C band. I was hoping to find that 9.3 station, but I guess it's not on today at this time. There's nothing there. So I'm going to tune from one end of the band to the other. I'd like you to do 2 things. One is watch the eye carefully and listen. You're going to hear the hiss rise up and go down, and then you're going to see at the same time the eye is closing a little bit and going back. That's my prediction. Let's see what really happens now. Yeah, for sure you can see the eye changing there. Why is that? If you notice, the radio gets quiet at this location on the dial too. As if there's something coming through. That's around 7 megahertz. But there's nothing coming through. Is there? So this is a strange operation in the radio. Okay, let's pick a band where there's some louder noise. I'll go to the broadcast band, stronger signals. Now the noise never goes away on this band, so the eye is always partially closed because the noise is as good as anything as far as the eye is concerned. At the same time, now, next study. I have a meter. I have my VTVM here connected to essentially to the AVC voltage. Is the meter drawing down the voltage? And that's the whole problem. If I didn't have the meter connected, we would see the full voltage, 15 volts, whatever it is. Hook up the meter, and right away it drops to maybe 8 volts because the meter is drawing power. Tiny, tiny amount, but the circuits we're trying to test are very, very high impedance, which means a tiny amount of electrical charge is causing large variations in the pressure, or the voltage inside the circuit. So bleed off a little bit of charge to run your VTVM, and the pressure, you're just like poking a hole in a balloon, you're letting the pressure out. It's tricky to realize that's happening. Fortunately, I have 2 instruments here to watch now. So when I hook up this meter, I want you to watch very carefully. What I suggest you're going to see is the pointer is going to go up and come down and stop. I'm not a little bit dramatic with my hand here, but it's not just going to rise up and stop. It's going to go up and then come back. Now, you know, these pointers have some momentum. They try to balance it out as best they can, but if you throw a sharp signal at a meter like this, the pointer will throw itself up higher because of meter movement momentum go up higher. But that's not what we're seeing here, I'm pretty sure. Okay, after all that talk, I'm going to attempt to hook up the wire and watch 2 things at once. So what we want to see is, let's watch this first. Does the meter go way up and then come back as if it's bleeding off a charge? And let's go where there's some voltage. Well, there is some. We know that from the eye, so we know there's something there. Okay, and you're trying to make a nice, neat connection here. Not block the meter. Oh, son of a gun. Okay, here we go. So this thing rose up to around 6. Some of that would have been pointer momentum. And then it came down slowly and settled into this 3 volt thing. There's no question. This meter is throwing things off. You know what I can do to even more make it dramatic? there's a large resistor in here that's in place when you're making DC measurements, specifically to reduce the draw on the meter. But you can't have that resistor in here when you're doing AC measurements. So there's a switch, a little switch right there. I'll switch the resistor out. And a dramatic change. I expected this to go, but it didn't. It makes no difference. What about on the eye? Okay, back to the eye now. I'm going to remove the meter, remove the load, and we'll see what the eye sees of that. Here we go. I'm watching that eye very carefully. Not a darn thing happened. I know you can't see it well in the video, unfortunately. Nothing happened to the eye at all. So, meter not affecting the eye, but meter not reading the correct voltage for where it's connected. Well, that's a darn problem. So we even if this is false, and before when I was getting a maximum of 7 and 8, if the meter wasn't connected, the true voltage would have been 15 or higher. Aside from that, I still see what I see on this eye, and I don't like it. So there's still something going on here. Trying to think of what to do next. Well, there could be component issues, resistors and stuff like that. There's no reason why there couldn't be those kinds of problems in here. Tracking that stuff down, tricky business. I think the best thing I can do right now is take a break and drink some coffee and ponder things. Figure out my next step here. Just came back from being outside battening the hatches because rainstorms are coming here today. Okay, now let's try this. Let's try a different meter reading this voltage here. Because the input impedance might be different. Now I don't think it is. Where can I put this? Put this here. I don't think it is. I think it's I think they're both 10 megohm inputs. Now first, with this meter connected, we'll connect this one. We'll see if this meter drops even further when this one's connected. So, ground one lead. Whoops, and touch here. Oh my gosh, I got this on. Reading resistance, reading resistance. Resistance is futile. Okay, now I'm looking more closely. Watching this meter first. Let's make it a little more sensitive. Is it dropping? It's doing nothing to that meter. Okay, and the reading I get? Huh? Huh? How come I'm getting that little reading? You know, sometimes I kick myself in the rear for double checking things. Minus 2.9. How can this be? Oh, no. Really? Is it that I don't have the ground connected from this meter? Oh my gosh, I don't. Hey! Mr. Technician, I think you need to hook this wire up here to get a good reading. Okay, lots of explaining needed here. Okay, first, is the eye moving? The eye is not changing. Why is this dropping right to nothing now? Anybody, somebody. Well, there's no signal. There's no signal. Let's go. Oh, yeah. Let's go back to the I've switched it off the broadcast band. Let's go back to the broadcast band where there's some action. Okay, now if I pull this meter ground off, how stupid can you be, man? Hook up your meters properly. when I was in college, I've told this story a few times, but I'll tell it again. I was in college learning electronics. We were working away at our desks, doing some mathematics, because that's what electronics mostly is, a bunch of mathematics. And all of a sudden the instructor, without any warning, said, "Do you know what the problem with these things are?" And he was holding up a meter, something like this. He was just holding it up in the air. He says, "Do you understand what the problem is with these meters?" And everyone's wondering, what the heck is he talking about? He says, "The problem with these meters is they always give you a result." And then he put the meter down, put his head down, didn't say any more. And I thought about this for a while. Well, what's he trying to say to us? He's trying to say to us that you just can't rely on what the meter says. You have to think about what you're doing with it, the influence that it's causing, all this kind of stuff. You can't just take the number off the meter. So I've never forgotten that. Probably one of the best lessons I ever got. Now, where does that lead us? Okay, so I'm going to double check this voltage now. I can do it properly. We're going to compare this to this. And we're going to watch and see if this drops. Does it drop? It does actually drop about a couple of widths of the pointer. Oops, I knocked this right off. Where'd that, I don't know. All kinds of thoughts went through my head there. I'm not sharing them. Here we go again. Okay, so on the little meter, it's reading minus 6.6. And on this reader, it's reading 6.3 or 4. That's pretty close. We should really check the zero on here. Zero is good. Okay, so I don't expect this meter to be perfectly accurate, but it's pretty close. Close enough for my work. So we've seen this meter not causing a drop. Hey, let's repeat that voltage thing, because I'll bet you that was a false thing too. So take this off. Now assumably the voltage on a couple of these tube grids just went up a little bit. I'm going to stick this back on and see if it does the down thing. I bet you it doesn't anymore. No, it just comes right up to the reading. Okay, that was a big run around just to find out I hadn't grounded my meter. But at least I figured that out. Now, none of this is affecting the eye. I don't need this meter here. Everything is accurate on the DTVM. You would think if the meter was pulling the AVC down that you'd hear it coming out of the speaker somehow. I didn't hear anything at all, so that's all a good sign. So now we can get our standard situation set up here. So we're going to go to which band do you want to do this on? We'll do this on the 25 meter band because that's where my signal generator is sitting. 11.770 megahertz. So we'll tune it in up here. 11.7 should be well down here. I think that's it, but I don't actually have it connected. It's still running on the antenna here. The radio's still running on the antenna, so we'll get the antenna off. So I think the signal generator's signal was making it to the antenna and coming out of the radio. Now we're going to put this on. Going through a little capacitor here as instructed. Where are you? Way up here. Didn't I align this radio? Is that really where it is? It's 11.83 or 82. And the signal generator says something quite different. Is that really the signal generator? Yeah, it is. So one way or another, this alignment's gone way out. That's okay, because I know you got to do the alignment over and over to get it all hunky-dory. Now, can we do the voltage test with this signal? Let me find a quiet spot here. Okay, so I'd say that's a quiet spot. And we will tune there. Gonna give it some juice. So this is similar to a sort of a decent signal on an antenna, but it's not particularly strong. But it's a really good response to the radio. We're at 727. 727's down here, so alignment's way out here. Won't worry about it though. Question now is, can we read a certain voltage on here? Swap tubes and see a different voltage. This is what we're after, ultimately. So let me just too much stuff in here. Fortunately, some of my stuff has wheels, so I wheel it out of the way. First, I'm going to change the output level on the signal generator just to verify. Actually, I'm going to calibrate it. So that'd be 1,000 microvolts now. That's 1,000 microvolts. And that's a pretty good signal from an antenna. A really weak signal is 5 microvolts. It'd be really weak. And maybe 40, 50 is what you kind of need to kind of hear. Okay, now if I leave everything just as it is, make absolutely sure the radio's tuned in properly here, because I'm going to be a little bit out. And I make that to be 7.2 volts on the voltmeter there. Well, let's call it 7. Because it depends if I'm, yeah, let's call that 7. It's right on 7 now. Full voltage on the radio. Everything's good. We can take a photograph of the magic eye. I'm just doing that over here with my phone. It may cause some interference. I'm going to take a shot of the magic eye position. There we go. So I can compare it. Still 7 volts. Good. Now I'm going to pull the tube and stick the alternative one in. That's this one. This is a stronger tube than this one. This is too hot to touch. Right on the edge. It is right on the edge. I wonder where your socks go. They go in my shop and they become rags. That's where your socks are going. I'm going to pull this out. This might be a little noisy. And I'm going to put this one in. Now, is that going to cause like a misalignment in the radio? I don't think it should, but I don't know for sure. So the effect we see here could just be from alignment issues. Boing! Wow, that ever boing into place, eh? Give it another moment. So this was reading 7. It's now reading 7.3. So we got a little bit of an improvement here. But I can't imagine it made much difference on the eye. Now again, at the risk of just looking at it, I don't see any difference. At the risk of causing interference on my video, well, I'd say that's a little more closed. Tricky to tell. I think it's a little more closed. Tune the radio, right? Oh, we can get more out of it. It does seem to have caused the tuning to go off just a wee bit. What happened on the eye there? Oh yeah, you can see it moving. Okay, now what if we give it a strong signal? Let's say as strong a signal as you could ever imagine hitting this radio. That would be something like that. Not closing. And we're getting a total of 10 over here. So it sure looks like the 18 thing is true. You need the 18 to close these right up. Well, there's lots here to think about. Is there lots here? First off, is this a problem worth chasing? It may not be. a little bit of weakness in the radio is compensated by turning the volume up a little bit in many cases, and you get basically the same result. Your tubes are getting weaker and the amplification's going down, but you're turning the volume up in compensation. It's probably not performing quite as well as it could, but would you ever notice? The average person would never realize that's what's happening. That's kind of where we are here. We think the output from the IF is a little low because of the AVC voltage it's generating, but there's other factors that could be doing that. The detector tube itself, two 6SQ7s, I changed them with better ones. I put in good ones. I put in ones that were really working well. Left both the 6SK7s as is. When I tested them, they didn't test like rockets ready to go to the moon. They tested more like low Earth orbit. Or is there something else I can work on in the meantime while I ponder the situation? I can work on a cup of coffee. I'm going to work on a cup of coffee, ponder the situation, try to figure out what I could look for at this point that might be a problem that I can fix. I'm thinking resistors. Resistors is futile. Now might be a good time to review the whole AVC circuit, how it operates, and that might help me devise an approach to determining if there's really a problem or what can be done about it. By the way, both my cats were lined up at the door to come in because the rain has started outside. So, hatches battened, cats inside. Fantastic. Okay, so we will start here. This is the end of the IF section of the radio. That's that middle third that I showed in a simple diagram. And out of here comes a radio frequency signal at 460 kilohertz. It's fed into this tube where it's rectified by the two diodes right there. And the rectified output is here. Now right here there's a branch. So one branch goes this way through a very large resistor and heads off to the tube grids where I have the voltmeter connected. And we know that poking around with this line here doesn't seem to affect the magic eye. Now, the magic eye is shown way the heck over there. Now, how do they get the eye signal? So this is just a diagrammatic thing. They've pictured it way over here. So they have to draw this line all the way through the schematic. It really does give you the feeling that this is an add-on. They stuck it out here because this is where they had some white space, the draftsman, to add this in. So perhaps they have a version of this without this guy showing. Yeah, because often the magic eye is just showing in here somewhere. But anyway, it doesn't matter. So let's follow that wire again. So we start up here. Out comes the rectified signal, and that's going this way through this resistor. Is not so big. What does it say? 35? 35K, it's not very big. We get onto a shielded wire. We follow the shielded wire, again, they aren't this long in the radio, to a switch. And this must be the phono switch. So normally when the radio is operating, the radio audio signal and this AVC voltage coming here, going through the switch, coming out, following this other shielded wire. Shielded because the signal here is easily interfered with. It comes up to the top of the volume control, and this is exactly where I'm clipping on. I'm clipping on my voltmeter right here. So that's right. I'm clipping the voltmeter here. I'm not clipping it over here on the actual grid circuit. So in fact, where I'm clipping it on is quite isolated from all this grid stuff, which is why we're not affecting these grid voltages. Just going back to this wire. Oh, right. So this leg goes down. I got it wrong. This leg goes down to the volume control and beyond. This leg is heading for the grids, but here's the tap-off wire that goes over to the magic eye, which is just another grid on it too. So it is mixed in with the grids here. but I'm monitoring the DC voltage over here on the other side of this resistor. So I don't really know what the real voltage is that's going up and down on these grids, because I'm not actually measuring that. I'm measuring something else on the other side of this resistor. So this resistor and the volume control sort of body resistor form a voltage divider. So this guy is 10 meg. No, this is 10 meg. This guy is 1 meg. So that's typical, 1 million ohms here. And then you have this here. This probably might have something to do with the fact that they try to stick a phono signal in here occasionally. Maybe this is, I don't know. Maybe this is, I don't know. That's the answer. So going back to the AVC side, what could be wrong? This resistor may have gone way high. It's not very likely. It's already pretty high, almost 5 megohms. It's not likely that it did anything because it's not really doing much. There's no current flowing through here of any significance. So, but it's possible. This may have gone high. We have other resistors in here. Any one of these may have gone off. And then they're all hooked up to the same line here. This is probably going to the grid way over here. So if this resistor is off, there's no grid current. It shouldn't be anyway. So shouldn't be any voltage drop. So shouldn't be any change. This is more about isolating away grids from each other. There's no DC flow of current, but there is a signal here. Come up 220, 220. So these are both the same size. And coming back here, because this is also going to the grid, there's no resistor in it. Just making observations here of how they've done this. Here's the AVC capacitor, 0.02. Change this early on, and then here's this thing. Oh, the gimmick. The gimmick which was untwirled when I got the radio. By somebody who was trying to fix it, I assume. Well, I twirled it back up and have left it. And what are the chances that untwirling that will boost the signal? So the proper value of this is discovered in the factory by cutting back a longer version of the twisted wires. You cut it back, cut it back, cut it back until you get the response you want, whatever that is. I wonder, we could experiment with that because it's easy to untwist and twist up again. Could check some of these resistors if I can find them. Okay, that's a plan. Poke around, check some resistors, see what the story is with this experimentally at some point, and yeah, check these. Yeah, okay, that's the plan. Good. Coffee works, you know. Here's something I forgot about. I forgot about these two capacitors, which I've overlooked, and I really should get rid of these now. I have one here, one here. There's another capacitor up here. This one's not likely to be bad. These ones aren't likely to be terribly bad either, based on testing of other capacitors that I've done. One is soldered right to the chassis, and the other one, well, let's see, soldered to the chassis, and the other wire comes up onto this. This is a basic volume control has 3 terminals on it. The fancier ones have terminals out the back, and these are used for various purposes: feedback, tone control, loudness. They have multiple purposes. So what exactly this capacitor is doing here? It's feeding through a resistor. There's a resistor right under my finger there. So it's a capacitor. Goes to a terminal strip, comes up through the resistor to the tab on the back, and then there's a capacitor here. The other capacitor, wow, okay, you know what, the other capacitor, okay, big deal on the other capacitor. Let's look at the schematic and I'll talk about that other capacitor there. So there are 3 of them that are there. two of them are potential targets for replacement. Let's look on the schematic here. Okay, so this is the volume control. And when you turn the knob, this piece with the arrow slides up and down on this resistive element here, up and down. What capacitors do we see? So this is the second one. I said, well, I'll tell you more about it when we look at the schematic. So let's do that right now. Look, the audio signal you're listening to is coming entirely through this capacitor on its way to everything else and out the speaker. If this capacitor is in big trouble, then the sound would be in big trouble. Typically, big trouble means loss of volume. Big trouble would mean this capacitor is actually broken and it's open circuited. You have nothing coming out of this radio. But the important thing to recognize about it, look at this dotted line here. So this dotted line is telling us that this is a shielded wire and a shielded capacitor. Whew. Holy schmoly. And this part is not shielded, probably because it's not practical to do something here. So they don't even bother showing it. But this again tells you how sensitive this is. Shielded all the way to this resistor, but then not shielded afterwards. This little dotted line here is indicating that the shield, which is probably a braided wire cover going around the wire, that is tied to the chassis. That's what this dotted line means. And this one here, this is a part that may or may not exist. And in our radio here, we have the 981X on the bench. This capacitor exists. This is a tiny one, 33 picofarad. So this is the guy I pointed to on the top of the volume control. I said probably no trouble with them, and there probably is no trouble. Now there's one more capacitor. The capacitor connected to ground and connected through a resistor to the, I guess that would, to the tab on the back. So here's the tab, and there's a resistor. Here's the resistor, and there's the capacitor, and there's the ground. It's got a note here, 981X. 0.02. Oh, 0.02 in the 981A, but it's a 0.005 in the X version. Okay, we should replace this. Now let's just think things through here. Now what if this were shorted right out? You'd have a shortened volume control, and I'm sure it'd be dramatic. And we would know right away something is badly wrong with the radio, I think. What if it's open circuit? Probably not. Probably wouldn't know anything's going on. What if it's no longer 0.005, now it's a 0.001 with a little leak in it? Well, this should be blocking all DC. If it's not, if it's leaking a bit, a little bit of current flowing down here, a tiny amount, 22,000 ohms. This is probably, I don't know, probably 2/3 of 1 meg, so this is pretty big. How would this affect the AVC voltage? Well, that's a bit of a stretch. That's a stretch. This one here, what am I going to do about this one? Now, in other radios, I have left this capacitor in place. Reason being, I don't have a shielded version of this capacitor to replace it with. I can put another capacitor in here, but it will be exposed to picking up noise. Hum, buzzes, who knows what might happen. Radio audio sounds pretty good, so I think we can assume this is working well enough. And if this one's leaky, because there's DC in here, some of that DC would get over here. Interestingly enough, it's a negative DC. So this will increase the negative bias on this grid, I think. And the influence of that, I don't know, to be honest with you. See, this is a 10 mega ohm resistor, and this is wide open. There's just a wire in space here. So this is a very, very high impedance circuit here. Tiny amounts of charge can affect its voltage, or the pressure inside this wire. Now, there's not much voltage coming here. It's only the AVC voltage, which we know is, 6 or 10 volts. If this were really shorted out, 6 or 10 volts dropped by this resistor, you get some weird effects here as you move this volume control up and down, I think, because you'd be shifting the bias on this. I don't know what that would really sound like. And the chance of this resistor being in trouble, I don't know, it can't be that great. What if it went to 15 megs? Probably just do the same job at 15 megs. So can these really explain the AVC, and is there really even an AVC problem, or am I just barking up the wrong tree? I'm going to change these capacitors and we'll see what effect it has. I've left all the equipment on, running idle, so hopefully we can just make this change and then test the radio and make a valid comparison. Yeah. Okay, got the capacitor hooked up and we're ready for a test. 50 volts, what's the I do? Radio open. 150, radio open. 250. This capacitor's in pretty good shape. Hard to see how this could cause a serious problem in the radio. But it's out now. We'll put the proper one in there. Can't imagine this is going to help the AVC mystery problem. Okay, new capacitor's in place there. Now the other capacitor, the one that's shielded, the metal shield is like a can on the outside of it. I'm rubbing my finger right on the metal shielding can. That makes me wonder if you could just kind of replicate this. Just take some kind of a metal tube and stick your capacitor in it. And, if you had to. I don't think we have to with this radio, and I don't think it's germane to the issue I'm after, which is the low AVC voltage. Now, did this capacitor help that out? I just can't believe it. I don't think it's even worth testing the radio yet. I think I got to go hunting for resistors, and that's going to be underneath here. That's what I'm going to do. Hunt down the resistors. Okay, let's see how this goes. Now, hunting down resistors. So I would like to locate this area here in the schematic. I can do that. That's not the right one. This one, this area, not that. This is the output here. I can find this 4.7 meg or whatever that is, 33. I think that's 33. You know what? I know where this resistor is already. So I'm going to show you that. So I'm starting with the second IF can and tracing that way. Just need a pointer. Okay, so second IF can is right here, right here. So looking now for a connection from one of these terminals that goes to a resistor like that, and then goes to a shielded wire like that. Because if you look on the schematic, you'll see that right after encountering this resistor, it goes to a shielded wire. So that's bullseye. This also looks like it's orange, orange, orange. That would be 33. That's a bullseye. Let's see if it's 33. Mostly when I'm doing these old radios, I don't do a lot of work on the resistors. If they're really bad, I find them. Of course, you end up finding them. But often I'm not going through trying to measure all these resistors. Many of them you can't measure. They're in a circuit. They can't be measured. You can maybe make some deduction from taking measurements, but okay, so we think that is supposed to be a 33K. Let's see, 33K in the circuit. What did we get? 36. $33, $36. Can't imagine that makes any difference. Okay, so check. check one resistor. Now this also should lead us to this one from this point, from the point towards the coil. So there's going to be another. Oh, no wonder you can't find these. So from this point, there's another resistor. You know what? There it is. Can you see it? It's behind this capacitor. It's going all the way up to here. Okay, and that is supposed to be a big one. That's a big honkin', almost 5 megohm resistor. Tangled up here. Okay, again, measuring it in the circuit. .9 megohms. So we can't be complaining about that one. That's. I mean, is there another possible resistor that could be? Those are probably the two key resistors on this circuit. Oh, let's follow this further. And it's going to be very difficult actually to try. Well, maybe not, because I can track back from the grid of the tube and find this resistor connected to this resistor. 220 and 220. Well, I don't know what else to do. I'm here now. Might as well do that. So we would want to find this on, this is the 6SA7, isn't it? Yeah, 6SA7. Yeah, it's got extra grids. Find the pin for grid 3. The pin for grid 3. 6SA7. Pin for, you think I memorized this stuff? 6SA7. Struggling to remember my own phone number these days. 6SA7. Looking for grid 3. Pin 8. I remember doing this. Pin 8. Pin 8 is grid 3. And how does that help us again? That gives us access to the first 220 resistor. So 6SA7 right up here. Pin number 3. This is a tough one to spot. The radio's not on, by the way. I'm not doing this with the radio switched on. He says looking over to make sure it's not on. there's the key up there. So that's 8. That's 8 right there. And then 8 should lead to a resistor. Oh, that'll lead to a resistor. Oh, yeah, down here. Right there. Supposed to be 220 and it's reading, you can't see it, it was reading 240. Nothing wrong with that one. Now that should lead us to the next one. So there should be another resistor on the end of the screen wire. I don't think so. Wasn't there another resistor? It's got the the gimmick capacitor there. There is a resistor visible right here. It goes to ground. Don't know what that is. Let's check the schematic again. So what we've done here is we found this resistor. And I'm thinking the other side should be connected to this one. Right like that. And then this guy, see this thing is connected right up here. Good. Where's this resistor? It's got to be there. Coming from the grid. Coming from the grid of the first RF tube. Is this by some chance how... No, we figured that out before. So, some radios, the AM skips this stage, and the AM antenna signals fed right to the second one, but that's not the case here because I have a coil down here. So what is this? What is this supposed to do? provide an AVC voltage. That's what it's got to be doing, just providing an AVC voltage. Well, we can track back from here. So go to this tube. That's a 6SK7. And what pin? There I go again here, 6SK7. Got this book from a guy I was working with, an older man who is long deceased now. When I was working, I was young. One day he comes in, goes, "Hey Jim, maybe you'd like this book," and he gave it to me. And I thought, yeah. I've been looking in this book almost every day since then. A little worn out, eh? Okay, 6SK7, back on target here. And this is going to the grid, so that's pin number 4. So we look at pin 4, 6SK7. That's this tube way up here. Why don't you just ride the elevator for a bit here? That's good. Pin 4. There's the key. 1, 2. That's 4. There's a resistor right there. Now this is an older style resistor. So the way you read these is the colors are body and dot. So this is red, silver, yellow. So red is 2. Silver, what's it doing there? I don't know. 2 something, and then this is a 220. That's a 220. 220K. That's the resistor. Okay, so now we're gonna take a reading here. Let me look down, 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 down. How about you old resistor? Old style resistor. 250. That's not the problem. That is not a problem. So what have we done now? Now we've looked at the circuit from the detector. Not paying any attention to any of these little capacitors. This is probably not even easily accessible. This one might be. But I don't think they play a role. We found this resistor is correct. This one's correct. These two are correct. We're really running out of stuff here. Fiddle with this thing. Okay, let's fiddle with this thing. See what it does. Can we measure the capacitance of this? If I put... I don't think so. There's too much other stuff hooked up here. I don't think we can measure the capacitance of that. Could try. I'm going to unwind it and see what it does. Now, it looks like it's affecting every band, probably in the same way. It's attached between the two grids. Yeah, I don't know. Well, let's give it a go. I'm down to the bottom of the barrel here. Well, I'm going to guess this guy's probable job is to stop oscillations. Well, unfortunately, my hard drive on my computer I used to make these video recordings got jammed, which happens if I just keep recording video and I don't pay attention, and then the recording stops. And unless I notice that, I'll just carry on in here and nothing will get recorded. And that's what happened. A couple of minutes of video. Now everything's turned off in here because I had to unload the hard drive and take some time dealing with the computer situation. I turned everything off, well, almost everything off. So rather than turn this on and demonstrate, I'm just going to tell you what happened. Can you see now the wires are not quite as twisted as they were? So by watching the AVC voltage and fiddling around with these wires using a tool, because I didn't want to stick my fingers in there, I resolved that this is the better position. They reduce the capacitance of these two wires by reducing their contact. And the result is I got another volt on here. So that's pretty interesting. That means I'm going to guess that somebody in the past, whether they knew what they were doing or not, untwisted this and discovered the radio worked a little better, and they left it untwisted. That's my story. All manufactured in my head. So where are we at now? Well, we're at a position where I really don't know what could be responsible for sure. I mean, I can take all kinds of guesses at this point. A lot of things I can't really do much about. How bad is this? Not bad at all. I mean, the eye doesn't completely close. It comes fairly close. The only thing that's really sticking out on this radio now is the C band, which appears to remain weak. So maybe I'll make that the topic tomorrow. Go after the C band tomorrow, and then that may be just about the end of the road here. I'm not too hopeful I'm going to figure out anything about that successfully. But you never know until you try. Okay, well, thanks a lot for watching today, and tomorrow, like I said, what did I say? I can't even remember already. My thoughts are already with what I'm going to do next in my house. And so I'm going to go. Thanks a lot for watching.